In decision theory, expected value of some future situation is essentially a weighted average of everything that could possibly happen then. You can see that even in this short little problem. There's a 60% chance of a loss of $100, a 30% chance of sales of $100, and 10% chance of sales of $200. What is the expected value of sales? Now, we can back out and treat this formally. Expected value, if you want to think about it as a formula, you need to add each probability times each possibility. And I should, speaking of being formal, these i's, they're index numbers, 1, 2, let's say capital N. Oh, all right, now, what's that formula supposed to mean? Oh, okay, this is implying capital N, that there are n future states of nature. There's a good terminology. These possibilities. The x here is the actual value of each of the future states of nature. To calculate the expected value of a situation, what this is just saying is that you pair up a possible outcome times the probability it will happen, and then you just add those up across everything that could possibly happen. Oh, all right, so whether you think about it that way or you just use this formula, what is the answer to this question? How do you work this? Well, you can see that there are 3 future states of nature here: a loss of 100, sales of 100, and sales of 200. And in each case, there's a probability associated with that. So to calculate the expected value, we say 60%, or in decimal, 0.6, 60% of, now, you may be tempted to write 100. Careful. First off, we're multiplying. 60% times the outcome. It said a loss of $100. So that's negative 100. That's something that's like a little sneaky about this problem, but that's the actual outcome numerically. Okay, now the rest of it's pretty straightforward. Plus take 30% of sales of 100, so that's a positive 100, plus take 10% of sales of 200. Just add all of this up. Well, when you add all that up, it comes out to a negative 10. Yes, a negative 10. The expected value of the situation is negative 10, or a loss of $10, to add some interpretation to it. So now the next question is also concerning expected value, except you notice that it doesn't have any percent signs. It doesn't quote any probabilities. Well, let's look at it. An ambulance generally transports between 1 and 8 patients a day if the ambulance crew reports no particular pattern. Within that range, what is the expected value? It's asking for the same thing that we were doing with sales, of the daily number of transports for this ambulance. Okay, now one important issue to recognize here is, what are the future states of nature? Because I said that the expected value, you multiply the probabilities times the value of the various futures. What are they? Oh, well, it says the ambulance will transport between 1 and 8 patients a day. Notice that's 8 different futures. Here's a day where they transport 1, a day where they transport 2, 3, 4, 5. I'm just doing it list style. 6, 7, can she count to 8? 8. So what this problem is saying is any one of those futures as a daily number of transports is, well, it said there's no particular pattern. Now, it does want to know the expected value, though. And you think, oh, all right, fine. I have those values for X in the formula, the values of the various futures, but it doesn't say anything about probabilities. As a matter of fact, it refuses to comment on that. There's no particular pattern. That is the same thing as the probability associated with each of these 8 futures being exactly the same. You say, oh, all right, so if I knew what they were, it'd be the same number for the probability of each one of those. Yes, And since 1 through 8 apparently for this ambulance is every possible future that any future day could take on, that means those probabilities would have to add to 1, right? Because you've accounted for everything that could happen, the probability has to add up to 1. Oh, so if they're all equal, that means the probability must be 1/8 in each case, or what is that, 0.125 or something like that? So I would say 1 times 1/8 plus 2 times 1/8 plus 3 times 1/8 plus 4 times, yes, to calculate the expected value. But I'll tell you a shortcut. If the probabilities are all the same, if all equally likely, and that's what we mean by no particular pattern, the probability is the same, that's the equivalent of just averaging this list. Just average. So I would average 1, 2, 3, 4, 5, 6, 7, and 8. I get that list averages to 4.5. which is what you would also get if you did it the long way and said 1 times 1/8 plus 2 times 1/8 plus 3 times 1/8 all the way down to 8. Check me on that. Nonetheless, the expected value of the number of transports daily based on this information is 4.5 patients.